This is the next question for design of Turing machine. So the language here says that we have to have n number of A's followed by m number of B's followed by again n number of A's. So the power of this A and the first A both are same. So equal number of A's should precede and follow some number of B's, and it is given that there should be at least one occurrence of these symbols because it is greater than equal to 1. So first of all we'll see a string which can be accepted by this language. So probably if I keep n as 1 because that is the minimum which we can have, so we have 1a. If I keep m also as 1, I'll have minimum 1b followed by a again. Number of a's here and number of a's here should be same. Another example could be 2 a's then 1b followed by 2 a's. So there can be multiple examples here. So this is another example, though there is no relation between number of A's and number of B's. So we can have more number of B's as compared to A's, but these A's should be of the same number. Now since there are same symbols which we have to check on the left side of B and also on the right side of the B, we can use the same replacement symbol for the Turing tape, and we consider that the replacement symbol which we'll be using is 1. That is, we'll replace these A's by 1 and also these A's which follow B by 1. So we'll consider an example string here and understand how we build the logic for this question. So the logic says that replace the first A symbol with 1 and then move right until we get the symbol B. Once B is found, we will again change the state and continue the movement further till the next A is found. Once the A here is found, we'll replace this A by 1, change the state and move back in the left direction until we find this 1 which we had replaced. So after doing this, we have counted that there was one A here and 1A here, and we have replaced both these A's by symbol 1. So we'll try to write the transitions till this point first, and then I'll let you know the logic further. Now what happens with B? We do not have to count the number of B's because we have to only count whether the number of A's here and number of B's here are equal or not. So we just have to skip all the B's which come in between these two A's. Okay, so let us see the logic with the help of state numbers. So Q0 will now get symbol A, and what was the logic? That we have to change the state and replace this A by 1 here. So the replacement symbol on the tape is 1. So A will be replaced by 1 and we continue to move forward, that is in the right direction. So now we move forward in the right direction. So Q1 will again receive a here. Though if the string is ABA, Q1 can get a B. So we'll write the logic for that later on, but now we'll consider what happens if Q1 gets a. If Q1 gets a, we simply have to move ahead, skipping all the A's and move in the right direction. So this is the skip operation because the symbol remains same and there is no change in the symbol on the tape. After this, what we have to do is we have reached here with Q1 and finally Q1 would receive B. So we'll write the logic what happens if Q1 receives B. So as discussed, we said that we are looking for B but we do not have to count that. So we'll simply change the state and move ahead without changing the symbol on the Turing tape. So we have moved further. This is Q2. Even if you get more B's operating on Q2, we'll still skip them and move in the right direction until Q2 encounters A. What should happen if Q2 gets a A? Now one more thing, it is necessary that you change the states here. Why? Because the symbol is changing and you want to consider that Q1 should get a B. And why? Because B is mandatory, because M is at least having value as 1. Moreover, after B, it is also compulsory to change the state here, which we will make this as Q3. Why? Because now you have to change the operation and go back. So Q3, replace this A by 1 and now continue the operation in the backward direction. So we are moving in the backward direction now. So this is L here. Now what happens? You have to keep on skipping all the operators which you get until you find this 1. Now what have we done up till now? We have 1 for this A and 1 for this A. That is, we have measured that there was 1A here and correspondingly 1A here to find equal number of A's before and after B. So for moving backward, if Q3 gets a B, we simply have to skip it and move forward. So skip this, change the state, skip it and continue the movement to the left direction, that is backward. Again, now if Q4 receives a A, you have to move in the left direction backward. So this will happen. So we have changed the state here. So this is what we have done up till now. We have 1 here, AA, BB, 1, AA and a blank. So Q0 operating on 1 will move forward, change the state. Q1 gets a, move forward by skipping this, because this A we just have to skip. Q1, Q2 skip, move forward. Now Q2 was looking for A and not for 1. See, so Q2 was looking for, if B is there it would skip, if A is there we have to change state and go back. But there is no transition written which says what happens if Q2 gets a 1. So we'll have to write the additional transition here. So if Q2 receives a 1, we simply have to move forward. So we'll just move forward by skipping this 1. So if Q2 now receives a A, this will be changed to 1, and we go back here with Q3. And we know what happens if Q3 receives a B, but we do not know what happens if Q3 receives a 1. So we have to write the transition for Q3 receiving 1. So this will simply skip this and move its backward journey. So this will be L here. So these were the additional transitions that were needed. We'll see how to do the termination for this. So after processing all the A's here, this will be the state where our string would be. So we don't know what happens if Q0 receives a B. We just have to proceed for termination. Why? Because we have counted for these 3 A's here, there are correspondingly 3 A's here. And if this B does not matter to us, so we'll just skip these B, skip all these ones, and if we get a B blank here, we'll say that the Turing machine should accept this string and halt. But if there was one more A remaining here, that means that the Turing machine will not move ahead and will not accept this string. So we'll write down the terminating transitions. So for terminating transitions, if Q2 receives a B, you just have to move forward by state change. Why? Because we do not want Q2 to appear in the initial state, because the string should always start with A. So now if Q5, we'll move Q5, do not change the state and move in the right direction, that is move forward. Again, if this Q5 receives a B, it does not matter, we skip that and move forward. Again, if Q5 gets a 1, that is also fine for us. So if it gets a 1, we'll skip all the ones and move forward here. And finally, if this Q5 receives a blank, we say that the Turing machine should go in the final state. Blank remains blank. Halt, that is we have accepted this string. But assume that Q5 receives a A at any moment here. This will not be accepted because that will not be our string which we were going to accept. That says that there are more number of A's on the right hand side if this Q5 receives a A at any point in time. So this is the terminating condition, and for writing this question you have to specify all the transitions, all these intermediate steps which I have shown. It is not mandatory for you to write them. You can write these steps in the rough margin just to understand what is going on. You have to list all the transitions together and then write the tuple for this machine, all the tuples. After that, you can also provide the transition diagram for this. If you do not wish to specify the transition diagram, it is okay. So either you have to write all these transitions, or you can only draw the transition diagram and write the tuple representation. This is the transition diagram for the question which we were solving. Another question is listed here. You can try to solve this question where all the 3 symbols are dependent on the same variable. That is, you want same number of A's followed by same number of B's followed by same number of A's. So what we'll do is simply change this first occurrence of A by 1, move forward skipping all the A's until you get the first B, replace that by 1. So correspondingly this A, this B is counted. Again skip all the B's if you have in middle. First occurrence of A should be replaced by 1. So we have correspondingly counted 1, 1, 1 of A, B and A here, then go back, do the backward transition, so that will create a loop, write the additional transitions and terminating condition. So you can try this question.